Hello students, welcome to this session. In this class, we are going to understand different forces in nature. Let us first understand what are the different types of forces we see around ourselves. The first and the foremost that we experience first hand, that is, we actually use it in our day-to-day life, is the muscular forces, right? We know that all living beings need energy for living. This energy is what we put into use to do different tasks, that is converted into force for doing various activities. The force is essentially produced by the muscles of our body. So when we are running, when we are writing, when we are even talking, we are putting our muscles into use for doing different tasks. In these all tasks, we are applying force, where we use the energy that we fetch from the food into the muscles, that is putting into function to do some task. So this force that is produced by the muscles of living beings is what we call as muscular force, and even one more name is also there, which is called as biological force. So when we are lifting, pushing, pulling, stretching, compressing, all the things that we do ideally is muscular force, right? Now when we are talking about what all we do with this muscular force, we can lift a heavy weight, we can actually pull a wheel cart, we can push a lawnmower, we can stretch a chest expander, we can compress a cotton bale, we can do much of our day-to-day tasks because of the muscular forces. Is there anything more to this? Yes. Remember, I told you it might be that you are applying force and you are not able to get the action or the effect of force out of it. For example, when you're pushing the wall, you're not able to move the wall. Why is it so? Because we are not able to apply the amount of force. The force that we are applying is not enough to push the wall. In some cases, we actually put into use the animals to do our task, that is put their muscular force into action. So if the force required is too large for our body, or we are incapable of producing it, we use the muscular force of animals. For example, bullock carts, they are used for plowing the fields. Or we know that horses have been used since ancient ages for carriages. Even we know that donkeys and camels are used for carrying heavy loads. And elephants are used for moving logs in the jungle. So where our muscular force is not enough, animals who are having greater power, greater energy than us, greater muscle power, they can put their muscular force into action, right? And even when the animals are also not enough to do certain tasks, we bring in the machines. So sometimes we use even non-living objects for performing certain jobs. For example, we use axe for cutting the wood, knife for cutting the fruits, vegetables, even meat, and we use hammer for driving the nail in the wall. So in performing all these activities, we use muscular force. So you will say machine doesn't have muscles. Definitely. But who are driving these machines? When I use a hammer, I'm using it in my hand. So ideally, I'm using my muscular force to nail the hammer, right? Or I am applying my muscular force of the arms to work on the axe for cutting the wood, or the knife for cutting the vegetables. They're not doing this on their own. They are using my muscular power, but they are increasing my efficiency, right? Let's go further and let's talk about the other kind of force, which is called the mechanical force. Now, when I talk about the mechanical force, this is the force that is generated by machines, which is we see around ourselves, like let's say a lever, a wheel, a axle, a wedge, or more. So when we talk about these machines, are they producing the force on themselves? The answer is no, but they are still helping us. How is it so? So ideally, no machine produces force of its own. In order to produce force, we must supply it with some kind of energy. The force used to run a motor car engine is produced by burning the petrol. So energy is required by us to put the muscular force into action. Similarly, the mechanical force, that is the machine which uses the force, must be provided with some kind of energy. For example, if I'm talking about a motor car engine, it produces the force because of the burning petrol, the energy given by it. The force used to run a steam engine is used by burning the coal. Or the wind turbines, they use the energy of the wind to produce the force, which is again used for grinding wheat. Or sailboats, they use the energy of wind to produce force which moves the boat. So all these are different machines which put into use one or the other form of energy to do the task by application of the force. So the energy of flowing water is also used to produce the force that is used to run the generators and produce the electric current, right? So different kind of forces are there. We have to understand where which force is coming into action, right? But the important or the basic line is all the forces can be classified as a push or a pull. Let's talk about the gravitational force now. Now this is the force which we experience all the time, but we do not know it. Which force? The force with which the earth attracts us. So we are able to live on earth. Why? Because the earth bounds us to it with the force called gravitational force. So we all know about Isaac Newton. He was the one who discovered the gravitational force. So whenever an object is dropped, it always falls towards the ground. This is something that we know. For example, the ripe fruits on a tree fall towards the ground. A stone on the top rolls downward if pushed. Everything and anything we see around ourselves always come back to the earth. Why is it so? Because the earth pulls all the objects towards its center. The pull exerted by the earth on the object is what we call as gravity or the gravitational force, right? So talking about this, even when we throw an object vertically upward, the force of gravity of earth acts on it. So when you throw a ball upward, what do you see? You see it first goes up, slows down, and then finally comes back only. So anything you throw up slows down, then stop, and then finally comes down. So it doesn't matter how hard you try, you're not able to send anything out. Right? Because the earth always have a gravitational pull acting on them. So if the force of gravity which gives weight to an object, this weight is going to pull back the object. Now what is this weight? This is very interesting. Now we understand mass is the amount of matter contained by the matter which is not affected by the force. But on the other hand, we are defining something which is related to mass, but it is a force. What is it? Weight of the body. So what you feel as the weight of the body is what? It is nothing but basically the force of gravity acting on it. The force or pull by which an object is attracted towards the earth is what we call as weight. Do you want to understand why we actually classify weight as a force? Let's do an investigation. It's very, very interesting. Let's say I have a rubber band, okay, and I just cut that strip of rubber band and hold it on a board, and I put a drawing pin over it. Now the rubber band will be like this. Now if I apply some force on the rubber band, it will be stretched, right? That means if I apply the force on the rubber band, it is stretching the rubber band. Let's not do this now. Now what? Let's take a stone. Now you know, if I hold a stone in my hand, what will happen? I will feel a force, something that is pulling the stone downward. Obviously, if I remove my hand, the stone will drop down. So that hand is holding the stone upward against the pull of the earth. So if we apply some force upward or against the gravity, it is keeping the stone in the hand. So if some force is pulling my hand downward, what is this force? This force is nothing but the force of gravity. So in order to stop your hand moving downward, the muscles of the hand is applying an equal amount of force in the upward direction. The force balances with the force of gravity and does not cause any motion. But what is this downward force you are feeling? You know, if you take a bigger stone, you will feel more force. You know, you will say that it is heavier. Heavier means you are comparing what? You are comparing the weight of the stone. Now this weight isn't the force. Let's go back to our experiment. What we were doing, we took a very small elastic strip or a strip of rubber band and we put it over a cardboard. The moment I stretch it or put a force downward on the rubber band, it stretches. Now I remove my hand, it goes back to its original position. Now I tie a stone with a string and I put the string or tie the string with the rubber band. You will see again the rubber band stretches. Now we just actually set up a understanding that the rubber band stretches when we pulled it downward. That means when we applied the force. But in the last, or we are not applying a force, we are only tying a stone to it. But by the very weight of the stone, the rubber band stretches, showing us what? The weight is the force. So ideally, we got to this point that yes, what is weight? Weight is basically the force of gravity that is acting on a body, right? This is where we end this session. We'll understand more in the next class. Thank you.